Hello everyone, welcome to the video lecture series of Theory of Automata and Formal Languages. So we are actually learning into unit number 1 regarding finite automata. So before this video we have learned about the construction of NFA from different regular languages. Now in this particular video we will learn about Epsilon Nfa. Okay, this is a special topic where actually this is the third type of finite automata without output. Okay, so if we talk about finite automata without output, we consist of three topics. One is your deterministic finite automata, another one is non-deterministic finite automata, and the third one is epsilon non-deterministic finite automata, that is epsilon Nfa. Okay, so actually this epsilon generally means what? Empty string, right? So I have written down few points which will be beneficial for you if you are making any kind of notes. Okay, so epsilon NFA generally this concept came from NFA only, and it generally have a comparison for NFA with epsilon NFA, and where epsilon NFA can be compared to NFA by saying that it contains states that produces empty strings. Okay, for example, if I look into this particular example, we are having state A, B, and D and C. Now we are having as we are having for A 0 transition, and for B we are having 0 transition. There is no transition for the input 1. As in this particular diagram you can look into this and you can say that the input strings are 0 and 1, right? Now apart from this we can also justify that this is an NFA. But how do you justify epsilon NFA? By looking at certain states which are producing an empty string. See, A is producing an empty string, B is producing an empty string. So we can directly say that this is an epsilon NFA. So how to get a DFA from an epsilon NFA? First you have to convert this epsilon NFA to an NFA, and then the process says NFA to DFA by using the subset construction method. Okay. Now, for conversion of any epsilon NFA to an NFA, you have to use the concept of epsilon closure. I'm giving you a little bit of brief about that. So what it means is that epsilon closure is finding of all the states which can be reached from the present state on one or more epsilon transitions. Okay, so there is a very good definition about this, but I will explain this particular scenario with an example right now. Okay, and then we will check it out how to convert this particular scenario to a NFA. Okay, so let us take the same example. I have taken the same example over here, and let us try to find out the scenario. Okay, how to find the epsilon closure? First of all, the scenario, the working principle asks that how to find the epsilon closure for every states. Now what's the scenario is that epsilon closure you have to find out for every states involved in this particular diagram. So I have to find out for A, for B, for C, for D. That means 4 states I have to find out, and I have to find out the epsilon closure for each and every state for both the inputs. Clear? How many inputs I am having? 0 and 1. For both the inputs I have to find out for four different states. Okay, so let us start off with state A, as I've already mentioned over here. So how to find out? You can use a particular the stuff that I'm showing over here is a rough work. Okay, no need to show in the exam. If you're attempting any kind of examinations, then don't show whatever I'm writing over here. This is one kind of a rough work that you can use it. And if you're attempting any kind of gate examinations or competitive examinations, then this particular methodology you can follow. But while writing in your examinations, I will let you know how to write. Okay, so first I will find out for A. Okay, and for A I will find out epsilon closure. Epsilon closure means 0 is the input symbol first I am finding out. So epsilon closure first I will find out initially, and then I will again find out after finding out with 0 I will find out the epsilon closure. This means that I will be finding out the transitions for epsilon closure, then again for 0, for epsilon closure. How to find out? I will let you know now. So first A, you can make a table right now and then you can write down. So A on seeing epsilon. First I have to go back to this particular diagram. A on seeing epsilon. Always remember that whatever epsilon is a null empty string, right? So if I am taking a state, say A, okay, if I am considering an epsilon transition, automatically we can say that A is having a transition over itself, because epsilon being an empty string, if I say that A is having an invisible empty string, then it's also okay. because it is an empty transition, right? So always remember that A on seeing epsilon, it first goes to itself. So I will write down A. Clear? Then A on seeing epsilon, next where it goes? It goes to B. Clear? See here, the most important line is that which can be reached from the present state on one or more epsilon transitions, is finding all the states. Very important thing, all the states. That's why I am using A. Okay. And one more thing, all the states means I will justify right now. Okay. A on seeing epsilon to itself, A on seeing epsilon to B, all the states. That means A on seeing epsilon, it also goes to B, and it also goes to D through B. Clear? So that means I have to also include D over here. This is how I have to find out. Clear? And any more epsilon closure you can find out? No. For through B I cannot find, I cannot move to C. There is no epsilon closure. I have epsilon closure only to D. So this is the part that I have reached, A on seeing epsilon. Now I have to find out A on for 0. How? For each individual state that you have find out. A on seeing 0, where it goes? A on seeing 0, it goes to itself. Clear? B on seeing 0, where it goes? B on seeing 0, it goes to C. Clear? So write down D on seeing 0, D on seeing 0, it goes to itself. Okay. Now again I have to find out the epsilon closure. Okay. A on seeing epsilon, already I have find out. A on seeing epsilon, where it goes? A, B, D. So let me write down A, B, D. Clear? C on seeing epsilon, first it will always go to itself. So let me write down that. Then is there any C epsilon transition from C? No. So it will be the final one. Now D on seeing epsilon, is there any transition for D? First it will go to itself. Any more transition? No. So finally what I can declare is that A on seeing 0, on behalf of epsilon closure, I am finally reaching to A, B, C, D. Clear? So I can make a table right now, and later on I will make it. So therefore A for 0, it goes to A, B, C, D. Later on I will make it, later on I will show you the table. Okay. Now I will find out for 1. Same way I have to find out for 1. Let me show you for 1 then. A on seeing epsilon is very easy. Already I have find out A, B, and D. Clear? Okay, so this is done. Now A on seeing 1. A on seeing 1, is there any transition? No. This will be empty, 5. Okay. Then B on seeing 1. B on seeing 1, it is going to, no, there is also no B on seeing 1, so this will also be acting as a 5. D on seeing 1, yes, it's going to itself, correct? Now this is 5, so no need for epsilon closure. Now left out with only one state, that is D. So D on seeing epsilon, there is no transition from D, so only D will come. So finally A on seeing 1, where it is going? It is going to D. So in this way I have find out for A. Clear? So A on seeing 1, it goes to D. Clear? So this is the final output that I have got for epsilon closure for the state A on seeing 0 and on seeing 1. Clear? In this way I have to find out for B, for C, for D. Okay. So let me find out. Okay, so I have already written down and I have taken the reference for this diagram. Okay, and initially we have find out epsilon closure for A. Now let us find out for epsilon closure for B. Now B on seeing epsilon, where it goes? B on seeing epsilon, first it will go to itself. And then B on seeing epsilon, it goes to D. Any other transition? No. Then I have find out B and D. So B on seeing 0, where it goes? It goes to C. And then D on seeing 0, it goes to D. C on seeing epsilon, is there any kind of epsilon for C? No. So it will be to itself. And D on seeing epsilon, is there any transition from D? No. So it will be the final one. So this will be the final one. B on seeing 0, it goes to CD. So I have used the transition table finally, and I have drawn for you. So B on seeing 0, where it goes? It goes to CD. See, I have already written this A, B, C, D, and D. This is what I have already got for epsilon closure of A. Okay, now I'm coming back to 1 now for the input 1. So B on sync epsilon, I have already find out B and D are the two important states. Okay, now B on sync 1, B on sync 1, it goes nowhere, so it is phi. D on sync 1, it goes to itself. Phi, that means it is done. D on sync epsilon, there is no epsilon transition from D, so it will be to itself D. So B on sync 1, B on sync 1 is where it goes to D. Clear? Now coming to the third step is for epsilon closure for C. Now C, okay, C on sync epsilon, C on sync epsilon, where it goes. Is there any epsilon transition for C? Okay, is there any epsilon transition for C? No, there is no epsilon transition for C. So what it will do? It will take itself. So that means C on sync epsilon, it goes to itself. And any other state? No other state. So C on sync 0, where it goes? C on sync 0. C on sync 0. Is there any transition from C? The 0 transition? No, there is no 0 transition. So it will be phi. If it is phi, then it will close over here. That means C, epsilon closure of C over the input alphabet 0 will be what? Over the input alphabet 0 will be what? Phi. Clear? Now we will look into finally for C epsilon closure for 1. Okay, C on epsilon closure for C, I have already find out C. Then C on sync 1, is there any 1 transition for C? Yes, it is going to be perfectly fine. Okay, now B epsilon closure. B epsilon closure already I have find out over here. So B epsilon closure means B and D. So B and D, you can write it down. Therefore, epsilon closure of C over the input alphabet 1 will be BD. So BD, I can write it down over here. Clear? So finally, I am left out with only one epsilon closure, that is for D. Okay, D on sync epsilon. D on sync epsilon. Is there any epsilon transition for D? No, there is no epsilon transition for D. Correct? So D on sync epsilon, it goes to itself. D on sync 0, where it goes? It goes to itself. So D on sync epsilon, where it goes to itself. Correct? Similarly, for D on sync epsilon closure, it goes to itself. Sorry. D on sync 1, where it goes to itself. You can see in the diagram. Then D on sync epsilon, there is no epsilon transition, so it will go to itself. So finally, epsilon closure for D over U 0 and 1 will be always D. Here also you can check it out. D is having a self loop, so definitely it will be D only. So finally for D, it is D. So this is the final transition table for NFA. From here you can draw the diagram. It's not a big deal. You know how to draw the diagram from a given transition table. So this is the final transition table that you have got for NFA. Okay. Then finally you can draw this diagram, and then you can convert further if the question arises that convert or find out the minimal DFA or find out a DFA for the given NFA. Then you can convert this NFA for the given DFA. Okay. So always try to find out. Now the main concept comes over here, that how to write in the examination. You can also write in this format, but this is actually not been asked. This is a rough work that we have to do it. One thing you can do is that you can use the concept of this transition function. Suppose I'm talking about this one. So transition function of B on sync epsilon, where it goes to B, okay, and D. So like this you can write it down. Then similarly, transition function of B on sync 0, where it goes to C. Then transition function of D on sync 0, where it goes to D. Correct? Therefore, transition function of C on sync epsilon, it will be your C only, and transition function for D on sync epsilon, it will be D. So this will be the final state that it is going on. In this way you can write it down, or I suggest that if you want, then I will upload a particular link where you can find out the formatted answers or how to write down if you're attempting for any university question papers. If you want that, please comment down below, or else after finishing off with all the videos, I will definitely try to share a link on that. Okay. Thank you for watching this video. Hope you have understood the concept of epsilon closure. It's a question that is being asked in a frequent way if you are attempting for any university examinations. Okay, and if you are attempting for any kind of competitive examinations, I would suggest that this is the best way to work on out epsilon closure way. Okay, so next class we will start off with the concept of finite automata with output, that is known as Murray and Mealy machine. So keep watching these videos and subscribe my channel so that I can you will be getting the updates with all the videos, and thank you for watching.